Hi, and welcome to this quick tool review. This time around we're going to take a look at an ultrasonic cleaner, a different version than I'd looked at in the past. The version I looked in the past is an industrial style one that both heats and has an ultrasonic cleaning bath. This particular model is designed for jewelry and is designed more for home. And I was just kind of curious about the differences between them. This one doesn't look like it has any heating, just for starters. This one is really inexpensive, $29.99 on Amazon. So the price is really inexpensive. It does a good job, that'll be nice. It has multiple time cycles, 5 different time cycles. It runs at 42 kilohertz, and the time cycles are 3 minutes up to, or I'm sorry, 1.5 minutes up to 8 minutes, which is not a long time. The industrial models will run longer. But again, they're designed for industrial. This one still claims to have a stainless steel tank with plastic surround, which is not a problem. So let's open it up and take a look. This ultrasonic cleaner is from a company called LifeBasis. Forgot to mention that at the beginning. My apologies there. Comes with the manual, probably in multiple languages. It's expensive foam packaging, this molded foam. That's about it. It's designed for jewelry and eyeglasses, so that could be really handy. It comes with a 2-prong AC cord. Inside, got a plastic bucket. So there's your stainless steel container. It's fairly small. I think this is half a liter or something like that. 17 ounces. Yeah, half a liter. And it has a plastic basket. My industrial one had a stainless steel basket. But if you're going to put something delicate in there, the stainless steel was not ideal. Like if you're going to do something like jewelry, I think the stainless steel was not the best option there for you. So the plastic will prevent the jewelry from getting damaged. Obviously what we're looking at is typically not jewelry, it's mechanical parts for cleaning. So this probably wouldn't be your focus, but if you're looking for a dual purpose, inexpensive item, this could serve its purpose. The manual is very, very readable. They did an excellent job. This plastic insert is for watches and is designed to hold your watch carefully in here so that it doesn't get damaged by being in contact with the stainless steel. This is for general jewelry or whatever else you're going to wash, clean in it. They say you can use tap water and dishwashing detergent, or if you really want, you can use specialized cleaning solution like this ultrasonic cleaning solution. I'd like to know what's in here. I'm kind of curious about that. It can run continuously for something like a half an hour, they say, but this thing heats up and it will either shut down out of safety or self-destruct. I'm not sure which. They're not specific. So that could potentially be a problem. The display on this guy is really dim, but you can see that there's multiple cleaning cycles there, up to 480 seconds. It's interesting they do it by seconds. 90 seconds is the shortest, and you hit play to go. Play and pause. That's interesting, just like a VCR. I know this is really dim. That should be improved upon, I think. Well, why don't we start with something that it's intended for, which is jewelry. And I'm going to go get some water and put in here with some dishwashing soap. Or actually, you know what? I'll use this cleaning solution. This is supposedly ultra concentrated, and it's 1 capful for this volume right here. There is a line on the back of the unit here for maximum water depth or cleaning solution depth, so don't exceed that. I assume it could overflow. And there is a connection between the plastic and the stainless, and hopefully they gasketed it well. You wouldn't want your cleaning solution to get in where the electronics are. That would probably be bad. And that might be one of the reasons they say don't overfill that. But anyways, my wife gave me some jewelry to clean in here. And it's kind of interesting because I think some of the jewelry is almost too big to even fit in here. So that's interesting to note. Yeah, it doesn't even easily submerge. They're tarnished, and I don't think it's going to fix tarnishing. I think what it will do is it'll remove skin cells that are stuck inside the jewelry. These are some old pieces my wife had from her family. There's another one. So it's not going to remove tarnish because tarnish is oxidation. So this is all silver, and it's not going to remove oxidation unless your solution can remove the oxidation. We're not quite up to the max line, so we'll raise it a little bit. I'm using reverse osmosis water, which is close to distilled. You probably don't need to go that far. I have really hard water, so I try not to use the hard water when I'm cleaning things because it can leave hard water deposits. So close the lid and start it up. And I guess we'll just let this go for an 8-minute cycle. There's probably not going to be anything to watch. The timer on the front does start to count down, which is interesting. It's counting down by seconds. I guess you can't see that. So the timer on the side counts down in seconds to let you know how much time is left. And they warn you not to overheat this guy. So like you can't do 5 of these 8-minute cycles in a row, because that's 40 minutes, and they say if you're going to run 30 minutes, you need 10 minutes cool down at least. And I think they prefer more because the transducer probably gets hot, or maybe the electronics. It is plastic, and plastic is a horrible conductor of heat. So this unit does not naturally self-cool very quickly. Plastic's essentially an insulator, so not an ideal container, but it's easy to manufacture inexpensively. One more late addition, my wife's wedding ring. Pop that in there, see if we can clean that up too. I know we don't often think of it as typical metalworkers, but jewelry making is metalworking, and it should definitely count. When I'm done, I'm going to straighten her wedding ring with this mandrel. It's designed specifically to straighten rings, to make them round again, because eventually they get a little bent out, especially delicate ones like her wedding ring. Down to the last 20 seconds. The right side of this is getting noticeably warm. Not hot, but just warm. The left side is still cool, which means either the electronics or the transducer's over here somewhere. It's kind of interesting. I'd actually expect the transducer to be dead center, and that's it. It's done. So the lid's nice because ultrasonic cleaners create very fine mist on the surface, and so you want to keep that contained inside here. And now I can pull this container out, which, incidentally, this one doesn't have heating, but I've got to tell you, it does heat the solution because the whole apparatus gets warm. All right, so I'm going to call this weird because I didn't expect it to remove any of the tarnishing on this, but it did. It removed quite a bit, actually, which is really interesting. Maybe the silver oxide on the surface is fragile and breaks off, because I thought you'd need a chemical process to remove that, but it actually cleaned that up really well. The tarnishing is gone in a lot of cases. It's not completely removed, but it definitely improved it. I'm really surprised about that. I'm curious if anyone knows more. Did a nice job cleaning up this class ring from 1966. Hey, look at that. That's the year I was born. That's not, I assume that's her grandfather's or something like that. So that one cleaned up pretty nicely. Her wedding ring cleaned up extremely well. Yeah, it got rid of the gunk that was under there. I guess skin cells get lodged in there. Yeah, that cleaned up too. I'm actually impressed. Yeah, all of this came out really good. So we're going to try and straighten her wedding ring on this ring mandrel, although I don't know if you can hear that, but they did a pretty rough turning on this. I'm a little concerned about trying to stretch this on here, because what they should have done is turned this better, but that's probably why it was inexpensive. Well, that's much improved, and it's definitely a lot cleaner. I give that a win. So before we leave this, I'd like to test a couple other things that may be a little more relevant to what we do. One possible use I thought was to clean my safety glasses that are always getting oil and cutting solution smudged on them like these, but doesn't quite fit. I could partially submerge them, but that's about it. Well, let's give that one a shot. We can do the shortest cycle for that. Kind of curious how that's going to do. They had had already cleaned off most of that quickly. Wow, that's kind of frightening. Holy cow. All right, that did a fantastic job. These have some scratches on them, but as far as all the grease and stuff, it removed it right off. Yeah, I've got some good scratch marks in here. These last me usually about a year, and then I swap them out. All right, so I'm putting some fingerprints on the lenses here. We'll run this on the quickest cycle, 90 seconds, and we'll see how well it cleans it off. I also get oil on the inside where the lens meets the plastic and it sort of wicks in, so maybe it'll clean that off as well. We will see. As far as my glasses go, they did a really nice job on those. You can see the fingerprints are all gone, so it does really agitate things well. Got a nice soap bubble here that's going between the whole arms of the glasses. You can see where the soap bubble connects to the lens there. That's kind of cool. I don't know if you can see that. See the soap bubble? So I didn't have any greasy parts, but a lot of times when you're cutting threads like this, you get a lot of chips and stuff in there, and so I didn't even make an attempt to clean this off. So you've got cutting fluid holding chips in there. So let's see what it can do for this. You can see the cloud where the oil's being dissolved off the surface. That's kind of interesting. So it's basically real-time dissolving the oil right off the surface of the part. It looks like the chips are going with it. So we've only been running 40 seconds, right, so far. All right, so I'm going to stop it after a minute, see where we're at. Looks like it's doing pretty well. By the way, while this is running, you can add time by just hitting the time button and it'll restart to whatever time you were on. So this was on 180 seconds and I touched it again and it started right over. And you can switch to other time cycles like down to 90 seconds, which is where I'm leaving this. But you can see the clouds of oil coming right off the part. That's very impressive. You can see the little cloud of vapor coming off of this. I'm pretty sure the actuator is over here somewhere. Either that or there's a resonance point, which is causing it to bounce up there. But yeah, it seems like the ultrasonic signal is strongest on this side. It really looked like it would be centered, but you know, maybe we'll open and take a look. Here's the part right out of the bath. There are still some particles on it, but it looks like it got mostly grease and oil off of it, just drying off the part. Well, so they didn't all fall off of it. Yeah, some of them are still in there, but the oil seems to be mostly gone. Maybe this would benefit from a longer running cycle. Of course, it wasn't also designed for this sort of thing, but I thought it'd be an interesting test and more applicable to the kind of stuff we do. By the way, that last example where I used the stainless steel bolt, I used some Vactra whey oil, which is really sticky to hold those chips on because I didn't have any recently cut parts. So maybe that's why it took even longer to get the chips off, because that whey oil is really sticky and really viscous. Another thing I noticed about this unit is there's no drain on it. Like some of the industrial units will have a drain down low, so it's easy to drain. This one does not, which means you have to pour it out. I'm guessing that they think you should just leave the solution in here all the time and, you know, clean your jewelry as needed and then just keep the lid closed when you're not using it. But because when you pour it out, it's going to go around this lip, and that concerns me a little bit just with water seal. So maybe they did seal it. Let's see if I can pop this guy open without damaging it. A lot of times they hide screw holes underneath feet because I don't see an obvious way to remove the top portion, but let's see if we can get in there. This one is no exception. So they use adhesive feet over the screws because they never expect you to get in here. So try and take them off without damaging the adhesive too much. I might have to add some myself. All right. There we go. Okay, so the circuit board, it's interesting. So the transducer is dead center on the bottom of the stainless steel unit. And it looks like they potted this stainless steel with adhesive into this plastic surround piece here. The transducer is pretty warm. So that'll heat your water for you. And it's this driver transistor here that got really warm. This has been off for a while and it's still pretty warm in here. So they've got one set of circuitry for the display and the touch sensors. So the springs on the side here are for the touch sensors and translate your proximity to touching it back to the PC board where it can be sensed. The touch sensor IC, I believe, is on this PC board along with the display. And the rest of the driver is on the board, on the main board down there. It's paper phenolic, which is not great. That's the cheapest kind of PC board, but this thing is 30 bucks. So, you know, you got to have sort of certain expectations. They do have a valley type intersection here between the top case and the bottom with a lip sticking down into that valley, but there's no gasket. So you would never want to submerge this to clean it. I'm sure that's pretty obvious, but it's only going to be very lightly water resistant. Both these transistors get pretty warm. This one at the end here gets much warmer than the other ones. And when this thing ran for 4 or 5 minutes, it got pretty darn warm. So you can see why they're saying make sure that you don't run this too long. What you could do is add a fan on this, but then you make this wide open to liquid intrusion, which would not be a good idea. This is not conformally coated, so they didn't protect the circuitry against liquid. And anyways, that's pretty much all there is about that. This is essentially an audio amplifier, except for normal audio frequencies. It's ultrasonic frequencies, which are just slightly out of the hearing range. We hear from like 20 to 20 kilohertz kind of thing, and this is 42 kilohertz, so this is a little outside our range. By the way, a couple observations about the transducer on the bottom. It's a piezo transducer, and piezoelectric materials like quartz crystal, if you apply electric field across them, they actually deform in shape. And so that's how they create an ultrasonic transducer. You can't just like use a normal speaker tweeter, for example, because it can't move that fast efficiently. But the piezo materials they can go much higher frequency than that, way up in the megahertz. Also, I noticed that this piezo transducer is mated specifically directly to the stainless steel case here. A lot of times they have a feed horn to focus the ultrasonic energy and set up a resonance at the frequency that's going to operate at. This one doesn't appear to be that way, but this is a pretty low power device. This thing uses only 35 watts. All in all, I think it's pretty decent value for $29.99 if you're just going to clean small things. For me, in my use, since I don't do really small things like watch parts or work on indicator parts, I think I'd look for a larger unit, but the quality's reasonable for the price. That's it. Thanks for watching. Hope you find it useful. Hope to see you next time.